Introducing TOR-3 from PDI. TOR-3 is new MIDI software that helps musicians and sound designers create pitch bend effects by using multiple instrument voices on multiple MIDI channels. It's the third installment of the TOR series. TOR-3 extends the pitch bend capabilities of multi-channel multi-timbral synthesizers by mapping MIDI scale notes to individual MIDI channels. This allows the pitch bend for each scale note to be applied independently, like a steel slide guitar, where one note of a chord might bend up, another bend down, while a third may sustain and not bend at all. This functionality does not exist for normal, non-MPE-enabled synthesizers. Let's dig in and see how TOR works and sounds. TOR-3 provides up to 16 voices of independent pitch bend control. It operates in two different modes: auto bend mode, and manual continuous controller bend mode. TOR-3 works by mapping incoming MIDI notes to independent MIDI channels and to specified outgoing pitches. You can assign the incoming notes to their default outgoing values, or you can assign them to custom tunings. TOR-3 operates in two modes: auto bend mode and manual CC bend mode. In auto bend mode, you select values for pitch and timing parameters. The application uses these parameters to automatically generate pitch bend effects for each of the 16 channels. Each channel is controlled independently. In manual CC mode, you map control of the pitch bend effects to external MIDI controllers. This allows you to manually control the pitch bend effects independently for up to 16 channels. You select between the modes by toggling the large mode button near the top right-hand part of the screen. In both modes we begin by assigning scale steps to MIDI channels. We then map each incoming MIDI note to an outgoing note. The incoming and outgoing notes can be the same, as in normal keyboard scales, or they can be mapped to create custom scales. You only have to set one instance of the scale. The software extends the scale mapping up and down the keyboard. Some functionality is shared between the two modes. We can turn channels on and off, and we can assign the same or different device pitch bend range for each channel. The bend range for each channel is set independently by specifying the number of semitones up and down. The MIDI specification allows for bending a pitch anywhere between 12 semitones up and 12 semitones down. This gives you potentially 2 octaves of pitch bend per channel. Let's take a closer look at auto bend mode. When auto bend mode is selected, certain functionality for manual mode is grayed out. Each MIDI channel has its own control strip that extends vertically from top to bottom. The control strips, and the functionality they contain, are identical for each channel. Next on our channel strip we have two dials. The first dial sets the percentage of how often the bend effect is engaged. Full left sets the percentage to 0, which means the effect will never be engaged. Full right engages the effect, 100% of the time. The up-down percentage dial works in a similar way. Full left sets the effect to bend from a higher pitch to a lower pitch 100% of the time. Full right sets it to bend from a lower pitch to a higher pitch, 100% of the time. The pitch bend range type button toggles between range and limits. When range is selected, the amount of bend is determined by randomly selecting a value from anywhere between the minimum and maximum values defined in the PB value range slider. When limits is selected, the amount of bend is randomly selected only from the minimum and maximum values defined in the PB value range slider. The tuning direction button toggles between out to in and in to out. When out in is selected, the note starts at the bended pitch value and then bends back toward the actual non-bended pitch. When in out is selected, the note starts at its actual, non-bended pitch, and then bends toward the selected out of tune value. The pitch bend back and forth button toggles between one-way, which has 2 right arrows, and two-way, which shows 2 right arrows and 2 left arrows. Selecting one-way triggers the bend effect in one direction only. Selecting two-way triggers the effect to first go in the selected direction, and then return to the starting point, by bending back in the opposite direction. The PB value range slider sets the minimum and maximum values for the amount of pitch bend. Depending on the PB range value type setting described earlier, the range selection will either set the minimum and maximum selected values as the only possible bend amounts, or it will set the limits of the amount that can be randomly selected. The buttons to the right of the PB value range slider allow you to set commonly used slider values with the click of a button. The first button toggles between R, for range, and ABS, for absolute. Selecting range means that clicking any of the buttons below will set the slider to a range of values. Selecting absolute means that clicking any of the buttons below will set the slider to a precise value. Clicking on buttons below sets the slider to a fraction of the pitch bend range amount. These buttons are only used to set the slider values. Their values in state are not saved with the preset. The bend time range max number sets the maximum amount of time, in milliseconds, that it can take for the bend effect to complete. You can set this number manually, or you can have it set automatically by enabling the link timing button. This links the bend time range maximum amount to the tempo selected by the BPM dial. The bend time range slider sets the range of times a bend effect can take to complete. Selecting the entire range, for example, tells the application to randomly select any value from 0 to 100% of the bend time range maximum described earlier. Selecting smaller ranges produces bend times proportional to the selected region. The buttons to the right of the bend time range slider set the slider value to discrete fractions of the bend time range maximum amount. These buttons are only used to set the bend time range slider value. They are not saved with the preset. The delay time number sets the amount of time that the application will wait before it begins the bend effect. If PB back and forth is set to back and forth, it also sets the amount of time the bend effect destination will hold before it starts to bend back to the original value. The delay scale percentage scales the delay time proportionally. This is useful if you want to set the delay time globally, and then scale each channel differently. It also allows you to achieve scale delay times that are longer than the selected delay time. Directly to the right of the last channel strip is a global channel strip. All of the parameter values in the normal channel strips can be set from the global strip. Changing any parameter value in the global strip sets the value for every other channel strip. Remember, the global channel strip only sets the values for the other strips. The global parameter values are not saved with the preset. Let's change from auto bend mode to manual CC bend mode. Note that most of the auto bend controls are grayed out. Manual CC bend mode allows you to independently control each MIDI channel from external continuous MIDI controllers. Note that a row of green number boxes located near the bottom, called manual bend CC value, have been activated. We will use these boxes to map MIDI controllers to the pitch bend of the selected channel. To map incoming MIDI controller information to a channel in TOR, we go to the Mappings menu at the top of the screen. From the Mappings menu, we select MIDI mapping mode. This puts the application into MIDI mapping mode. Now, to map a channel for external control, we click on a manual bend CC value number box. Then we wiggle the continuous controller we wish to map to this channel. Note that the value of the selected number box changes, as does the bend status slider. The controller is now mapped. You can repeat this process with each of the 16 channels. When you are through, just hit the Escape key on your computer keyboard to exit mapping mode. Your external MIDI controller can now send independent pitch bend information to each of the mapped channels. The monitor section shows which channels have been activated by an incoming note. The monitor will light up even if the bend effect is not turned on for that channel. The bend status slider shows you the pitch bend data that is being output in real time on the channel. The middle line means the actual pitch is sounding, with no bend in either direction. Values above and below the line show the amount of pitch bend being applied. This amount is proportional to the bend range set at the top of the channel strip. The 14-bit PB value shows you the current value of the pitch bend data being output. The 14-bit value shows you a range between 0 and 16,383, where 0 is maximum bend down, and 16,383 is maximum bend up. The mean value between the two, 8,192, equals no pitch bend up or down. The note out frequency displays the frequency of the unbended mapped note out pitch in hertz. The bend sense value displays how much the current note is being bended, in cents, which are 1% of a semitone. The bended frequency displays the current frequency of the bended pitch in hertz. Let's take a look at the settings on the right. These are global settings that affect all of the channels. We've described the mode button functionality earlier. Clicking the button toggles between auto mode and manual CC bend mode. The Reset on All Notes Off button enables functionality that resets all channel pitch bend values to none whenever there are no notes currently being held. That is, pitch bend will be set to 0 for all channels whenever note offs have been received for all note ons. Be careful with this setting. Just because you release a note does not mean that it stops sounding. Many sounds have long release times. In those cases, releasing all notes will send pitch bend information before the notes have stopped sounding. As you'd expect, the MIDI section controls how the application interacts with external devices and sources. Clicking the Scan Ports button tells the application to search for available MIDI ports. Use this button if you have connected a new MIDI device after you started the application. The MIDI in port lists all available MIDI ports. The port you select will be used to receive the note and control data used by the application. You can receive on all channels by setting the channel number value to 0. Or, you can specify a receive channel. Selecting a value from 1 to 16 will ignore incoming data from all other channels. The MIDI out port menu allows you to select from a list of available ports. All data generated by the application will be sent out the selected port. Turning on the Through button in the MIDI section passes any incoming MIDI data directly to the output port. This merges the outgoing processed data with the original incoming data. If the Through button is on, clicking on the Filter Notes button will not pass any note data through to the output. All other MIDI information will be passed through. If the Through button is off, the Filter Notes button is set to off and made inactive. Turning on the Mixer button displays a simple volume and pan control mixer for the channels. Any settings you make in the mixer are saved with the preset and will be recalled upon selecting the preset. Turning on Use Preset Ports saves the selected MIDI ports with the preset. When it's on, the MIDI ports you used when you last saved the preset will be applied when selecting a preset. When it's off, the application ignores the saved preset port information, and leaves the preset selection as it is when presets are selected and changed. In the clock section we specify how the application gets its timing information. If internal is selected, the application generates its own timing information. When MIDI beat clock is selected, the application will get its timing from a MIDI port, selected from the menu right below. If UDP beat clock is selected, the application will get its timing information through a proprietary, networked, P-clock protocol. The UDP port number is specified here as well. Turning on the link timing function connects the internal or external clock information to the channel's timing parameters. The BPM determines the number of milliseconds per beat. This becomes the default amount for the bend time range maximum, and the delay times. The bend time range maximum is also called the max time, for short. This allows you to easily set the bend effects to occur at musically and rhythmically useful times. You can also scale the max time value by editing the BPM multiplier parameter. A value of 1 leaves the max time value unchanged. A number greater than, or less than 1 multiplies the max time value by the selected amount. The scale settings parameters specify how you want to map incoming notes to the outgoing pitches. This complex functionality will be described in depth in another video tutorial. For now, we're going to make sure that we set both our steps/voices and our scale range parameters to 12. This means that our scale will have 12 notes, and those 12 notes will span one octave. You might have guessed that this describes a normal chromatic scale. In this case, we can set the scale start value to any C note octave. Let's use middle C, which is C3. Setting that the global transpose value transposes the output pitches by the number of semitones you select. This only affects the output notes. It does not change the pitch map or other scale settings. Some MIDI devices use a single program change number to select the sound. Others, with more than 128 sounds, use a combination of a bank controller number, a controller value that describes which bank, and finally a program change value from 0 to 127. The program change section allows you to send program change messages to your external multi-timbral instrument. To send a program change to just one channel, set the curt channel value to the channel you wish to send the program change, and then select the program change number. Clicking on the Send to All button will send the selected program numbers to all 16 channels simultaneously. For Kurzweil PC4 users, we've added the ability to select banks and programs with one PC4 program ID. You can take a snapshot of your settings and save them as presets. To save a preset for the first time, just shift-click on any of the gray square slots in the matrix at the top. The color of the slot will turn blue. The blue color means that a preset is currently stored in that slot. To select and activate a preset, click on any blue slot. The slot will turn green. This shows you which preset is currently active. You can name each preset and provide some comments by typing in the text boxes provided. To save an edited preset, shift-click on the green slot. This will update the preset to the currently displayed settings. To delete the active preset, just click on the trash can icon. This will clear the preset. The formerly green slot will turn gray. TOR allows you to save 69 presets per project. Each project also saves the external mapping information and the preset client object file. To save data as a new project, just go to the Application File menu and select Save Project As. When prompted, select a location for your project, give it a name, and click on the Save button. The preset data file, the mapping file, and the preset client object file will all be saved in a newly created folder that has the name you specified. After the project is saved, you'll see the project name appear above the preset comments text box. In this video, we've seen a lot of what TOR-3 can do. But we don't have time to show you its complete capabilities. Advanced features, such as scale mapping, MIDI mapping, keyboard mapping, and client list customization will be the subjects of future videos on this channel. We're also preparing a sound demo that shows how TOR-3 can be used to create unique musical effects that can enhance any production. So, subscribe to this channel, and stay tuned.
Hi everybody, I'm Alan Dudek, the developer of PDI Media Software. Thanks for watching our video. I hope you find our products interesting and musically useful. You can download our applications on Gumroad. Please subscribe to this YouTube channel for updates on this application and for video demonstrations of our other software products. You can also visit us on Facebook at the PDI Media Software Users Group, or if you have any questions or comments, just email directly at adudek@columbus.rr.com. Thanks for watching, and I hope to hear from some of you very soon.